Okay, so the most common way we look at this Gibbs energy, the way we commonly look at this written out, is that we use this form here with H and Ts because since we're considering constant pressure process, H is equal to the heat exchange with the surroundings that occurs in our system. And so we often write out that delta G equals delta H minus T delta S. And that, again, has to be less than or equal to 0 for a spontaneous or equilibrium process. And this is probably the version you are familiar with and that you've seen many times before, probably even starting possibly from high school chemistry, definitely in general chemistry. And so this is our condition for spontaneity for a process. So let's think about what this implies. Remember, this is happening at constant pressure, so delta H is equal to Q at constant pressure. And we're also seeing that the entropy change, again, this is our system entropy change. We're not considering the system and the surroundings. But what we can think of as happening here is that the delta G here incorporates all of the entropy involved in thinking about what's happening in terms of the second law of thermodynamics. Right? In the second law of thermodynamics, for an isolated system, which means the whole universe, if a process is going to be spontaneous, it has to increase entropy. And so we can see this term here is directly that entropy of the system. Right? What's the entropy change in the system? And it matters what temperature it's at, how much that matters, right? Because that entropy change is related to temperature as well. But if the entropy of the system is increasing, right, if this is positive, then that's going to tend to be a spontaneous process. That isn't sufficient, right? But it'll tend to be a spontaneous process, right? It'll lead to, because of our negative sign here, right? We have a negative sign here. That means that this is a positive entropy change in our system is going to tend towards spontaneity because we have an overall increase in entropy of our total universe. Now, the other side of this is that we also have the heat exchange with the surroundings. So we have the delta H side of this as well. And the release of heat into the surroundings or the absorption of heat from the surroundings also contributes to the overall entropy change for the whole universe. So we can think of delta H, the heat, being related to the entropy change, delta S, for the surroundings. And so if we are releasing heat into the surroundings, right, if delta H is positive, if we is negative, then that will overall lead to an increase in entropy in the surroundings. Because as we release heat out, that will, increase entropy. We're dispersing the energy more broadly. And so that will tend to lead towards a spontaneous process as well. But if we have delta H is positive, right? If we had this, so this one we're thinking about exothermic, we're releasing heat. If delta H is positive, that's endothermic. We are absorbing heat, right? Heat is leaving the surroundings and going into the system. That will tend to go towards a non-spontaneous process. But there's a balance here between what's happening in our system and what's happening in the surroundings. And so there are some processes that could happen even if the entropy change of the system is negative. If it releases enough heat into the surroundings, the overall entropy change in the universe is still positive, and so the process can be spontaneous. Whereas that's not the case, right? If you have the entropy change of the system being negative and also it's endothermic, that's a process that just can't happen, right? If you have positive delta H and negative delta S. And so we can consider this sort of for all the possibilities, right? We can draw out a little chart, right? If we have delta H, delta S, delta G, and just think about the signs that are possible, right? If we have a positive delta H and positive delta S, what are the possible signs that delta G could be? Well, if delta H is positive and delta S is positive, we could have positive or minus. We could say it depends, because it's going to depend on the temperature of the system and how large those positive values are. What about if we have both negative, right? Negative delta S, negative delta H. we'll get the same thing. That'll depend. Here, the negative delta H would tend to lead to a spontaneous process, but the negative delta S would tend to not lead to a spontaneous process. So there's going to be a balance here. All right, what about if we have a negative delta H and positive delta S? Well, delta G will always be negative then. And that process will always be spontaneous, no matter what the temperature is. For these ones where it depends, the temperature is going to be a big factor. And if we have a positive delta H and negative delta S, this will always be positive, and so this will never be spontaneous. So this would be a case of a process that could never happen without some external energy put into the system to drive this process. And so that sort of covers all of our possibilities, right, between exo and endothermic and the entropy change of our system.